just to learn this. Okay, just to learn this. Have to move on the slides.
Sorry.
Can you help me how to move on the
I think
slides?
it's just this.
Is it one? Okay, yeah, then better. Okay. My name is Heina Vogel from the Norwegian University of Science and Technology, and I am co-authoring this paper, Project Flexibility and Lean Construction, with Professor Glenn Ballard. And in this work, we approach lean construction and especially the loss planner system from an uncertainty planning and risk management point of view. And we identify particularly effective loss planner practices in order to handle uncertainty and also less effective practices. And we base our understanding on long-term research engagement in two cases, an oil field development case Glenn will talk about later, and a case of shipbuilding for advanced marine operations. And based on this research, we understand now that the less effective practices actually relate to uncertainty that is difficult to anticipate and therefore difficult to manage by traditional buffering approaches. And Glenn will introduce now the different uncertainties arising in construction projects before we discuss the strategies appropriate to handle them.
Okay, thank you. Okay. So what we offer as a distinction, and what we're doing this for is this is intended to develop a framework within which to extend last planner to master scheduler. Right? But we need to know what we need to pay attention to in that process. Right? And so we think that it's important to distinguish these two, statistically predictable variation and low probability, high impact changes. You can buffer the first, you cannot buffer the second. Right? So we need different strategies for mitigation. So I'm going to give you quite quickly, because I think what I'm going to present, the buffering of statistically predictable variation is quite well understood in our community. I think the second type is not very well understood. Okay, I'm going to skip through. You can read this, of course. So I distinguish between stable and unstable processes, and perhaps the easiest way to understand that is through the statistical process control. Right? So here we're showing a process that is unstable because its range of variation, unacceptably unstable, right? Because its range of variation is not consistently within 3 sigma of the mean. Okay, so I want to just illustrate some of these methodologies for dealing with statistically predictable variation. This is from work I did in oil field development with a company called Energy. This was back in 2000, which is a joint venture of Exxon and Shell. It's a very big operation. And what I did first, one of the first things when I first got there, I noticed that there was huge variation in workload onto the production system. And the production system here has the job of designing wells, drilling them, extracting the oil or gas, and putting it in the pipeline, at which point it becomes available for sale. Right? So from spending money to making money. So what I discovered that huge variation, and I predicted that if we could, that it was a function of uneven load on the system, which is a fundamental type of waste in lean. Right? So I did a couple of different things. I restructured the system along to reveal the different steps in the process and assigned individuals responsible for each of those steps, and used the last planner system to plan and coordinate flow through that system. Right? I then tackled batch, and I did two things with batches. First of all, I changed the batch size, and they were submitting into the system at the front end approximately 50 wells at a time. Okay, but they were paying no attention to the tack time, the average time to complete complete those wells through the process. They had a TAC target of an average of 2.1 wells per day. They didn't have it, we created it, but they already had it implicitly. Right? And then we redesigned, we restructured the composition of wells in a release down to 8 in a release from 50, and to the average TAC to the extent that we could, right, in the selection of wells. Does that make sense? Not vigorously. Give me confidence. Okay. And then a couple of other things that are there. We use different types of buffers. We re-engineered the well mix, as I mentioned. We introduced a decoupling buffer after drilling, because drilling was the major equipment constraint. Right? We had to optimize it to the extent that we could using that equipment. But we didn't want to disturb downstream functions by just letting work flow into them. So we used a pull system from that point. We allowed drilled wells to ebb and flow, right, over time, but within a predictable, preset range. Okay? So many things happened there. And, oops. Oh, but you don't have, I thought we had a slide showing the change in cycle time for wells. And in the first 3 years prior, we had this graph, and the cycle, the completion time for a unit, a well moving through that process, was essentially looked like a chaotic system. It was totally unpredictable, huge range in dispersion. And then we reduced that range, and we reduced the cycle time by 32%. Okay? And Exxon and Shell really liked that. So, and we took 25% of cost out of the system. God, I'm sorry. Stealing. Can we steal from these questions?
Thank you. Okay. I talk about the variation type 2, which is we call low probability, high impact changes. It's difficult to anticipate ahead of time. And this we observed mainly in the advanced shipbuilding industry, and it relates mainly to technical changes in design specifications, because both the operations of the vessels and the building of the vessels is on the edge of known technology. So changes in design and technical specifications is an inherent property of this business, the way of doing the business. And one example, it's obvious that such changes are difficult to be handled by buffering strategies. Why? Because changes in design may change the project network structure itself, not only the duration of an activity, which can be handled by a buffer, but also the activities to be performed and their sequencing. So this is a much more complicated problem than only treating uncertainty in project activity durations. So one representative example from the maritime industry is scope outfitting equipment, uncertainty in scope outfitting, uncertainty in design. And information design uncertainty on scope outfitting is usually coming after the project start, and it's not uncommon that it's coming late into the execution phase. To give an example from our case, 2-3 years ago there was a vessel when the customer came 2 months before the delivery and wanted complex firefighter installed. So of course this is not the type of change which you can buffer for. So this picture illustrates the deck of a vessel where equipment, scope outfitting equipment is to be installed. Okay, and as you can see here, the fixed place of the equipment is specified. So the common approach in the industry is to build in equipment foundations into the steel structure of the block units with a specific space for the equipment. And this is a good solution from a design perspective, but with costly loopbacks on a large number of ready finished documents when scope outfitting changes come late in the process. So how can we do it better? Can we plan it differently to eliminate this waste, which actually is quite large? So one example, one solution approach also coming from the industry is to deck the prow of the vessel. the entire deck with a thicker steel sheet to preserve the option to install different equipment than anticipated. So this actually, okay, thank you. This, of course, this option has some initial extra costs, but also preserve the flexibility to adapt changes with least costs. So what we have inside into this solution, we have two different flexibility strategies. One is postponement, to decide what equipment to install later on the vessel. And the second one is hedging. Hedging means that we pay something, we buy something to prepare for late changes with least disturbance. Just want to give two examples we identified on hedging strategies within the lean construction industry. The first one is, you know about, the set-based design I don't talk about. And the second one, which we actually applied in this example, which we showed, is consolidating negatively correlated activities. I don't talk about this now, we don't have time, but this knowledge is coming from financial portfolio planning, product portfolio planning. And the general behavior of correlations is that consolidating negatively correlated activities will reduce the risk, while consolidating positively correlated activities will increase the risk. And the better strategy for positive correlations is to develop buffers, while for negative correlations is flexibility. So what we suggest here is that in order to move from reactive to proactive strategies, we need to create flexibility in planning. Postponement is the second flexibility strategy we mentioned, and the loss planner is a good example on this strategy. Finally, one more note, team flexibility. So after we emphasize the shortcomings of the RPS in respect to handling this type of uncertainty, we also see that the RPS actually in some cases effectively handles this type of uncertainty, especially if this can be handled within defined time and constraints. And we see that the RPS facilitates the development of responsive teams to the constraint analysis. Through constraint analysis, we may identify alternative solutions in light of uncertainty, and also make a commitment upon a solution approach. We also refer to the work of Italian Sachs, where the author from the lean construction community, where the authors emphasize that even incremental implementations of the loss planner system improve the social network, hence the performance of project groups. So what we say here is that in order to move from reactive to proactive approaches in project planning, we need to create flexibility first in planning. And in order to do that, we have to move to the master plans and the project execution strategy and integrate into the loss planner framework. And the second one, we have to focus the social behavior aspects of teams, the human aspect in flexibility. Do you want to close it up?
I think we're out.
Yeah,
This is just a sketch of the overall set of distinctions, the framework we're going to use as the basis for going forward. Thank you. Well, we'll find out. They judge whether we did it well or not.
Okay, guys, we have time for one or two very quick questions.
I'm not Marisaki. Just very quickly, I guess when we don't know where equipment is going on a slab, then we increase the capacity of the slab, so when we put it anywhere, that's an example of hedge. Is that right?
Right. Yeah, because it's a cost. It's like buying insurance, right? You know it's going to cost you something because you just paid for it. Right. Thais?
In my experience with the research in CII, people want to leave the design out of the discussion, but when we talk to the suppliers, who might be part of the problem of the variation, they say that they receive horrible specs from companies that might or might not be the ones you study. So how are you dealing with that? Because that's going to bring a lot of variation, because they have to sweep through the specs and produce a project, product that might get to the site and they say, no, this is not what we asked. But the specs are from another
perhaps just a quick response. The things that the problems we saw with design changes were not typically because someone had built to the wrong specification, but because the client was in a very dynamic business situation, and they were trying to respond to late-breaking information about their client preferences. So.
I guess my point is, suppliers, they complain that the companies give the specs that are not actually related to their projects, and they waste time doing things that don't relate to the project, and they are put under a lot of pressure to deliver, and they might be late when they are doing things that are not needed, actually.
Yeah, they shouldn't do that.
But we always look at the design house. We always say, oh, we are not looking at the design.
Oh, no, we have to look at the design. I mean, that's the source of uncertainty, right? In one way or another, when the way you described or the way that we were dealing with it.
Okay, guys, we have, thank you, Glenn.
Thank you.
We have one more because we have 4